put that in there. That's when I know when to start the cut of the video when I'm editing. Yesterday we left off with me showing you guys the basics of objects, the basic concepts behind object-oriented programming, and the basics of how you manage particles. I'm going to go over that again super quickly, like super quickly. Here are the basics. We have our ES6 object here. ES6 is the latest standard for JavaScript. And I love this syntax. It's so simplistic. I'm so happy that it's this simple. But basic class particle, we have a constructor that defines certain properties of the class. If you want other properties outside of the constructor, like a function, you just put the name of the function. There's no function blah. So it's very semantic, very easy to read. Each particle is responsible for drawing itself. It knows its x position. It knows its speed. It has its gradient, and we're going to do some really cool stuff with this next tutorial. And then it draws itself. Context, begin, path, arc. Again, 0 to 2 times math pi is a circle. We're using the gradient that we're defining here as the fill style, and we're filling it, no stroke. So that's how we're drawing each particle. So that's the particle object. Object defined. Now we're going to look at the application itself. So var canvas document.query selector canvas. That's us just simply grabbing this canvas here. Again, this is all of the HTML that you need for this specific example. So we're grabbing the canvas by its tag using query selector. Here's where we define the canvas context. Again, you'll note that I haven't defined it yet. We have the number of particles that we want to have on screen. So I have a pretty beefy computer, and this seems to be pretty performative, up to around 5,000 particles. So we'll just throw it up to 2,000 just to flex. Gravity is what we're going to be going into today. We have our init function. So this is where we take the number of particles that we've decided upon, and we are pushing new particles, so this object, one at a time, into this particles array 2,000 times. That's what this function is doing. Then we have a function called process frames. This is going to be processing your hitboxes and driving, really driving the engine behind your logic. So in this function, we are using a request animation frame. This is built into JavaScript that at about 60 frames per second, it's going to call process frames. So you can see that this is a recursive function, and basically that means it's just going to go on forever. There is no stop. We have the basics. That was yesterday. So now we're going to move on for this, and we're going to add some forces, add some boundaries, and there's multiple ways of doing this. And the way I'm about to kind of show you guys is not the way we're going to be doing it in the future. I just thought it was a neat way. I was playing around yesterday trying to figure out kind of ways to make this more interesting. So first off, we're going to start by, instead of having everything moving in explosion in all directions, we're going to have everything shoot upwards. So right here in the constructor of the particles, and this is where we're kind of getting into the very, very basics of behavior, right? So right here, what this is telling us is that the particle is going, y and x is going to have a random velocity, and that velocity is going to range between negative 2.5 and 2.5. Epic code montage. I love it. But now, because we want everything to go up, I don't want this negative 2.5 afterwards. So instead, if I just save this, you can see immediately that everything is moving upwards now. So then the other thing is, well, where do we want this to start? Right? Well, I'm going to want it to start at the bottom of the screen. So again, what we have here is previously we're telling everything to every single particle to start from like the dead center of the screen. But what we can do here is we can say, hey, let's start all of the y's at inner height, maybe inner height minus 10. So it's just slightly above the bottom of the screen. And there you go. You can see what that looks like there. But then if we really wanted to, there's a couple of things we can do here that's cool, right? So what we could do is we could set x to 0. So this means that when we fire off the particles, they're just going to go straight up and down. Their x is not moving when the speed is 0 for x. And what we can do here, instead of having everything dead center, is we can just say math.random. Did I accidentally press insert? I bet I did. Window dot enter width. And what this should do is should have all the particles going straight up at different velocities, but all across the bottom of the screen. Let's see if we're right. I am wrong. Oh my God. My brain. Times. Holy. This is what happens when you get old. See? Now it's like your favorite soda. Bubbly, bubbly, bubbly. Bubbly, 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 But, I mean, okay, cool. We have a bunch of bubbles, and they're all going up. So I got a lot of eggs. And I keep them in the couch. Here, let's add 2 so that the slowest particle will be moving at a speed of 2. So everything goes up now. It's like, yay, hooray for particles. But now we want to add gravity. So let's add gravity to this. So we saw the little sneak peek of what I was doing here, in which we have var gravity. Can save that like that. And then basically what we want as well is in the particle, we need a current speed and we need a original, actually to be more accurate, y speed. So current y speed and original y speed. And original y speed is just this dot y speed. And we can actually do the same with this dot current speed because, hey, it's going this fast at the beginning. So now what we should be doing is passing gravity into our particles. So now, if I'm doing this wrong, I apologize. I am doing this wrong. So in the constructor, sorry. I know too many programming languages, so I apologize. Sometimes I get lost in syntax. And then we should be able to say this dot gravity equals gravity. And we can actually test this quickly by going console.log gravity. Hello. Who dis? See? Gravity. So we're passing gravity in. That's fantastic. Okay, so we've passed gravity in. So how are we going to use these new properties? If we go down here, the first thing we're going to do is we're going to change this dot y from this dot y speed to this dot current speed. And up here, we're going to say this dot current speed equals this dot speed minus this dot original speed times this dot gravity. And then last but not least, this dot speed y equals this dot current y speed. Whoa. All right. Let's give this a little more speed here. So let's bump this up so you can see it a little bit better. So there we go. We now have gravity affecting the particles. So to quickly explain what's going on, we have gravity. I set gravity down here at 0.02, which is the inverse of 0.98. I'm basically using pseudo physics to have an effect that's similar to gravity on Earth based on the velocity and assuming that the weight of each particle is 1 gram per cubic centimeter of volume. Anyway, sorry, that's getting really nerdy and has nothing to do with what we're doing right now. Anyway, that's why I chose that number. We're passing gravity into the particle. We have the current speed, the original speed, and gravity. Every time we run, we're going to set the current speed equal to the speed y minus the original speed, which was set right up here when we put in the random value, times the gravity value that we passed in. So we're slowly, exponentially, as been said, pronounce Beanixfo. Nice. All right, I won't get it wrong. Thank you, Beanixfo. So based on the original speed, we always have to apply against the original speed. Now, we don't need to recalculate this. Like, we could very easily just do something like this and say gravity increment. I'm not spelling that right. Is it increment? Yeah, perfect. So gravity increment equals this dot speed times just gravity. Don't even need this dot gravity. So passed in value. And the reason this will work, so we can then take this and put this here. The reason this will work is we're only defining the original speed once in the constructor. Does that make sense to everybody? Especially you, Morgan. What do you think? Do you understand what's going on here?
Yeah.
Awesome. All right. So let's see if this behaves the same way. It doesn't. What did I do wrong? I didn't put this. Save. There we go.